Hello everyone, welcome back to Inspire Logic Show. So in today's video we are going to learn about OE means overall equipment effectiveness. So this is one of the most important performance measurement tools used in lean manufacturing. So OE helps us understand how effectively a machine or a production process is being utilized. It identifies losses related to availability, performance and quality. So let's start about this OE topic. So I will explain in one by one in clearly. So let's start. So first of all, what is OE? What is OE? OE stands for Overall Equipment Effectiveness. So OE is a lean manufacturing performance measurement tools used to determine how effectively a machine or a production line or a piece of equipment is being utilized. So that is called OE. In simple word, OE tells us how much of your plant production time is actually being used to produce good quality product at the expected speed. We helps answer three important questions. What was the machine available when you need it? And did the machine run at the expected speed? Did the machine produce good quality products? That three question is the most important in OE. So these three questions are represented by the OE factors. So in OE there are three factors. One is availability, second one is performance, third one is quality. So and the basic OE formula is OE equal to availability into performance into quality. Availability into performance into quality. And why is OE important in lean manufacturing? In lean manufacturing, focus on creating more value for customer while the eliminating waste. A machine may appear to running well, but there may be hidden losses such as machine breakdown, long setup times, material shortages, waiting for operator, slow machine speed, small stoppages, production of defective parts, rewards, setup rejects, process instability, that type of factor. So OE helps make these losses visible. So OE helps make these losses are visible. For example, suppose a machine is scheduled to operate for 8 hours. It may look like the machine worked for the entire shift. However, it stopped for 45 minutes because of the breakdown. It stopped for 20 minutes for the material changes. It ran slower than the standard speed. It produces some defective parts, and these type of problems are common. The machine may have been busy, but it is not fully effective. So we convert these losses into a measurable percentage. The three main components of the OE. So OE consists of three major components. One is the availability, second one is performance, third one is quality. And therefore OE equal to availability into performance into quality. So let's understand each one of the simple terms. First one is availability. What does availability means? Availability measures how much of the plant production time the equipment was actually available to operator. So again, availability means how much of your plant production time the equipment was actually available to operator. One second. So in simple words, availability tells us whether the machine was running or when it was supposed to be running. Availability means availability tells us whether the machine was running or when it was supposed to be running. The main losses affecting availabilities are availabilities are the equipment breakdowns, machine failures, long setups, changeover, adjustment, waiting for maintenance, the other plant production stoppages. So availability formula equal to first we need to two important times. First we need two important times. Plant production time, and this is the time during which production is actually scheduled. For example, a factory has an 8-hour shift. 8 hours equal to 480 minutes. Suppose there is 30 minutes plant lunch break, and then for plant production time is 480 minus 30, and plant production time is 450 minutes. And the lunch break is not normally considered an availability losses because production was not planned during that period. Operating time. So operating time and operating time. Operating time is the actual time the machine was running. For example, plant production for 50 minutes. Machine downtimes 15 minutes. Therefore, the operating time is 450 minus 50. Operating time is 400 minutes. So availability formula equal to operating time divided by plant for production time into 100. So therefore availability equal to 400 divided by 450 into 100. So availability equal to 80.89 percentage. So the machine was available for approximately 88.9 percentage of plan for the production time. Example of the availability. Imagine a machine is scheduled to production for 8 hours. Shift information, shift duration 480 minutes, plant break 30 minutes, plant production time 450 minutes, machine breakdown 30 minutes, setup or changeover time 20 minutes. The total unplanned or unavailable time equal to 30 plus 20, 50 minutes. So operating time equal to 450 minus 50, so 400 minutes. In availability equal to 400 divided by 450 into 100, so 88.89 percentage. Therefore, availability equal to 88.89 percentage. This means approximately 11.11 of the plant production time was lost due to the downtimes. Then what is availability losses? What are the availability losses? The availability losses are mainly related to the machine not running when it should be running. So common examples includes equipment breakdown. The machine was suddenly stopped because of motor failure, sensor failure, bearing failure, electrical problems, hydraulic problems, pneumatic problems, PLC issue, and that type of equipment breakdowns are there. So setup and changeover. This is the equipment breakdown first one, and second one is setup and changeover. The machine need to be stopped to change product, tool, die, mold, material, program, production specification. The machine need to be stopped to change product, tool, die, mold, material, program, production specification. That is the setup and changeover. So third is the adjustment. The machine is stopped because of the operator or technician need to adjust tool position, temperature, pressure, alignment, speed, machine setting. So this is the adjustment time. And fourth one is material shortages. So the machine cannot run because the raw material is unavailable. So that is the material shortages. Fifth one is waiting for maintenance. The machine is waiting for maintenance personnel, spare parts, or technical support. So that is the waiting for maintenance. And the seventh one is performance. So what is performance means? So that is the available, everything is over. Then second one is performance. So three major factors. So one is availability, second one is performance, third one is quality, and this is called performance. So what does performance mean? Performance measure whether the machine is running at the ideal or standard speed. In simple word, performance tells us whether the machine is running as fast as it should So a machine can be available and running, but it may run slower than its designated speed. So that is the performance also waste now. So for example, I will explain that. So a machine is capable of producing 60 parts per hour, but doing actual production, it produces only 50 parts per hour. So the machine was running, but it was not operating at its expected speed. So this is a performance losses. So performance losses are generally include. So first one is small stops like the machine stops for a short period. Example, sensor blockage, a part jam, minor machine interruption, material positioning problem, tool clearing, operator intervention. So a machine may stop for only 20 seconds or 1 minute at a time, and these small stops can be difficult to notice individually, but over an entirely shift, they can create a large loss. And second loss is reduced speed. So the machine is running slower than the standard or ideal cycle speed. For example, standard cycle time is 10 seconds per part, 10 seconds per part, but actual cycle time is 13 seconds per part. The machine is producing part, but it is running slower than expected. So that one also speed is reduced speed. Then performance formula. A common OE performance formula is so performance equal to idle cycle time into total count divided by operating time into 100 percentage. Idle cycle time into total count divided by operating time into 100 percentage, where the idle cycle time equal to faster achievable cycle time under defined condition. Faster achievable cycle time under defined condition. Total count, total number of parts produced, including good or defective parts. Total count, total number of parts produced, including good or defective parts. Operating time, operating time equal to actual running time. So, for example, in the performance, so ideal cycle time is 10 seconds per part. Ideal cycle time means standard cycle time is 10 seconds per part. Total production equal 2000 parts. So operating time equal to 400 minutes. Operating time means in per shift 400 minutes. So convert operating time into seconds. So 400 minutes into say 60. So 24,000 seconds. Now calculate. Performance equal to 10 into 10 means idle cycle time into total production 2000 were divided by 24,000 into 100. The performance equal to 20,000 divided by 24,000 into 100. So performance equal to 83.33 percentage. So therefore performance equal to 83.33 percentage. This means the machine was operating at approximately 83.3 of its ideal production speed. Understanding performance with a simple example. Imagine you have a machine that should produce one part every 10 seconds in the minute. So 60 divided by understanding the performance with a simple example. Imagine you have a machine that produce one part every 10 seconds. So 1 minute equal to 60 divided by 10 means it's a 6 part. So 1 minute equal to 60 divided by 10 parts. So 6 part. So in 60 minutes equal to 60 into 6. So 360 parts. So 360 part. So the theoretical production rate is 360 part per hour. But because of the small stop or reduced speed, the machine is produced only 300 parts. And the machine was running, but it did not achieve its potential production rate. The difference is a performance loss. The difference is a performance loss. And the last one is the last factor is quality. So what is quality? So what does quality means? Its quality measure how much of the produced part are good parts compared with the total number of parts produced. In simple word, quality tells us how much of the production was made correctly the first time. If a machine produces 1000 parts and 950 are good and 50 are defective, then the quality of the percentage is 950 divided by 1000 into 100. So that is called 95 percentage. Therefore, quality equal to 95 percentage. So quality losses. There are also quality losses are there. So quality losses. Losses can include first one is scrap. So a products that cannot be used or sold. Cannot be used or sold and must be discarded. Example: wrong dimensions, cracks, surface defect. Surface defects, wrong assembly, increased weight, incorrect weight, leakage, welding defects. Again, examples are the scrap, wrong dimension, cracks, surface defect, wrong assembly, incorrect weight, leakage, welding defects. And second one is reworks. So the product does not meet the requirement the first time and needs to additional work. For example, a component is produced with an incorrect hole diameter. So instead of scrapping it, the company may correct it through additional machine. This is the rework. Even though the product may eventually become acceptable, the additional work is represents a loss. So another defect is inequality is startup rejects. Starts up rejects. When a machine starts after setup, changeover, maintenance, tool replacement, and this is the first few parts may be defective while the process is being adjusted. There are startup quality losses. So quality formula equal to the basic quality formula equal to good count divided by total count into 100. Good count divided by total count into 100 where total count equal to good count plus the defective count. So total count equal to good count plus defective count. So quality example, suppose a machine produce total 2000 parts. Good parts are 1920. Defective are 80. Quality equal to 1920 divided by 2000 into 100. So quality equal to 96 percentage. Therefore, quality equal to 96 percentage. The machine produce 96% of the good parts. And the complete OEE formula and all of the overall the factor the complete OEE formula. Now we combine availability, performance and quality. The formula of the OEE equal to availability into performance into quality. So important. When using percentage in calculation, convert them to decimal value. For example, availability equal to 88.89%. So 88.89 equal to 0.889. So performance equal to 83.33%. So this is equal to 0.833 percentage. Quality equal to 96 percentage equal to 0.96 percentage. So therefore, y equal to 0.8889 into 0.833 into 0.96. So overall, y equal to approximately 0.71 percentage. Convert to back to the percentage. Y equal to approximately 71.11 percentage. Therefore, the machine y is approximately Therefore, the machine OE is approximately 71.1 percentage. So completely OE example for beginning to end. So let's take a realistic manufacturing example. Imagine a company manufacture metal components. A machine is scheduled for 8 hours per shift. So step 1, shift information. Shift duration 8 hours. Convert into minutes 80 into 60 for 80 minutes. Planned lunch break 30 minutes. Therefore, planned production time 480 minus 30. So planned production time equal to 450 minutes. Step 2, calculate availability. During the shift, machine breakdown 25 minutes, changeover to machine breakdown 25 minutes, changeover 20 minutes, adjustment 10 minutes. So total downtime equal to 25 plus 20 plus 10, so 55 minutes. So operating time equal to 450 minus 55, so 395 minutes. So total available time is 395 minutes. So availability equal to 395 divided by 450 into 100. So availability equal to 87.78 percentage. 87.78 percentage. Okay. So let's talk about the step 3. Calculate for the performance. Suppose ideal cycle time is or standard cycle time is 12 seconds per part. So total production equal to 180 parts. Operating time equal to 395. Total production 1800 parts. So operating time equal to 395 minutes. So convert operating time equal to 395 into 60. So equal to that one converted in minutes now 395 into 62. So 23,700 seconds. So performance equal to 12 into 1800 bracket divided by 23,000 divided 23,700 into 100. So performance equal to 21,600 divided by 23,700 into 100. So performance equal to 91.14 percentage. So let's calculate about the quality. Suppose total parts 1800, defective parts 54 parts, good parts 1746. So quality equal to 1746 divided by 1800 into 100. So quality equal to 97 percentage. So in totally overall equal to now availability equal to 87.7%, performance equal to 91.14 percentage, quality equal to 97 percentage. So therefore we equal to 0.8778 into 0.99114 into 0.97 into 100. So we is approximately 77.6 percentage. So we approximately 77.6 percentage. Then what does an OE of 77.6 percentage mean? So what does an OE of 77.6% mean? So it does not mean that the machine was physically running for only 77.6 percentage of the shift. Instead of it means that after considering availability losses, speed losses, quality losses, so the equipment achieved about 77.6 percentage of the theoretical effective production capability during the planned production time. So this is why OE is powerful. A machine may appear to be performing well, but OE exposes losses that are otherwise hidden. The six big losses in OER. So the six big losses in OER. So a traditional OE system commonly group equipment losses into six big losses. They are divided among availability, performance, and quality. So we factor six big losses: availability, equipment failure; availability, setup and adjustment; performance, idling and minor stops; performance, reduced speed; quality, process defects; quality, reduced yield, setup losses. So let's understand them one by one. Total losses. So first loss one is equipment failures. First loss one is equipment failure. So equipment failure occur when the machine stops because of the breakdown. Example: motor failure, bearing failure, gear failure, electrical failure, hydraulic failure, pneumatic failure, PLC failure. For example, a machine stops at 10 a.m. because of motor fails. So maintenance repair it and the production restart at 10:45 a.m. So downtime equal to 45 minutes, and that's 45 minutes is an availability losses. So loss two, setups and adjustment. Loss two, setups and adjustment, and this occurs when the machine needs to be prepared for another product. Example: so the setup or adjustment. This occurs when the machine needs to be prepared for another product. Example: tool change, die change, mold change, product change, program change, material change, machine setting, trial production. This is the setup or adjustment losses. Example: product A requires one tool and product B requires a different tool. Changing for product A to B takes 40 minutes and those 40 minutes reduce availability. Lean manufacturing attempts to reduce these times through method as SMD or single minute exchange of die. And third process is idling or minor stops. And these are the short interruption. Example: part stock in machine, sensor not detecting part, small material blockage, automatic cycle interruption, operator clearing a jam, minor machine fault. These are the idling or minor stops. For example, a machine stop 20 minutes during a shift. Each stop lasts approximately 1 minute. So total loss equal to 20 into 1 means 20 minutes. Although each stops look small, together they can create a significant production losses. So loss 4, reduce reduce speed. The machine is running but slower than the idle speed. The machine is running but slower than the idle speed. The machine is running but slower than the idle speed. Idle cycle. Example: so let's say the machine is running but slower than the idle cycle. Example: idle cycle, so 10 second per parts. Actual cycle 12 second per parts. Reduce speed. So example: idle means standard cycle time 10 second per parts. Actual is 12 second per parts. The machine is running continuously, but it is not achieving its expected output. This is a percentage of losses. Possible causes include poor tool, poor material, operator method, machine condition, process instability, consecutive operating setting, equipment limitation. So loss by process defects. Process defects. These are the defect produced during normal production. Example: dimensional defects, surface defects, assembly defects, welding defects, leakage, incorrect weight, incorrect color, incorrect specification. Example: the machine produce 1000 pieces. So 50 pieces fail inspection and those 50 pieces represent quality losses. Those 50 pieces represent quality losses. So another loss is six loss is reduced yield or startup losses. This occurs particularly during startup after changeover, machine setup, maintenance, tool replacement, process adjustment. For example, after changing a mold, the operator produced 50 trial pieces and the past 8 pieces are rejected because temperature and pressure are not yet correctly adjusted. Those 8 pieces are startup quality losses. So OE and the hidden factory. OE and this is the one more topic. OE and the hidden factory. So OE and the hidden factory. OE and the hidden factory. So one of the most important concepts related to OE is the hidden factory. A factory can lose significant production capacity without adding another machine. A factory can lose significant production capacity without adding another machine. For example, a machine theoretically has the capacity to produce 1000 per shift, but because of breakdown, changeover, small stop, reduced speed, defects, it produces only 700 good parts. The machine has lost due to opportunity to produce 300 additional parts or additional good parts. The lost capacity is sometimes described as part of hidden factory. So one helps identify where the hidden factory is being lost. OE is the only simple machine of time. This is a very important point. Many people confuse machine uptime with OE. They are not the same. Suppose a machine has 95% uptime, and that sounds excellent. Suppose a machine has 95% uptime, thus that sound is excellent. But imagine that if the runs at only 80% of expected speed, quality is only 90%. Then we equal to 95% into 80% into 90%, so 68.4 percentage. So a machine can have high uptime but relatively low. This is why we consider three dimension. This is why we consider three dimension. So time plus speed plus quality. This is the OE quality. So it's time plus speed plus quality. This is the OE dimension. OE dimension. Time plus speed plus quality. So OE and lean manufacturing. OE is strongly connected to lean manufacturing because lean focus on on waste elimination. The common lean waste often remember as TMUs. Transportation. T means transportation, I means inventory, M means motion, W means waiting, O means overproduction, O means overprocessing, T means defects, S means skills or unused talent. So we particularly, so this is at the seven waste in the T modes. So we particularly helps identify equipment related losses associated with waiting, defects, overprocessing, unnecessary downtime, reduced production capacity. So Y should therefore not be viewed as that of number. So it should be viewed as a loss identification and improvement tools. OE and TPM. OE is closely associated with TPM. So TPM with the total productive maintenance. So TPM aims to maximize equipment effectiveness through so preventive maintenance, autonomous maintenance, plant maintenance. There are so many maintenance are there in that TPM. So first one is preventive maintenance, second one is autonomous maintenance, third one is plant maintenance, fourth one is the early equipment maintenance management, and fifth one is quality maintenance, operator involvement, continuous improvement. So we provide a measurement system to determine whether their activities are actually improving equipment effectiveness. For example, before TPM, we 62 percentage. After maintenance improvement, we 74 percentage. The improvements suggest the equipment related losses have been reduced. OE and Kaizen. Kaizen means continuous improvement. We can use to identify whether the Kaizen activities should focus. Suppose a machine has availability 90%, performance 70%, quality is 98%, and the biggest problem is performance. So therefore instead of focusing mainly on quality or breakdown, the improvement team should be investigate why is the machine running slowly, Are there small stops? Is the standard time, is the standard cycle time correct? Is the tool worn? Is the material causing problems? Is the operator method consistent? This makes improvement activities data driven rather than assumption driven. So, example, finding the biggest OE problem. Finding the biggest OE problems. Suppose three machines have the following results. Machine Y availability 90 machines availability, performance, quality and wood. There are three machines. First machine 95% availability, 70% performance and 98% quality. Then Y is 62.2%. Machine B 80 percentage, 90 percentage, 98 percentage. So Y equal to 74.54 percentage. Machine 3, machine C 90%, 90%, 80%. So E equal to 64.98%. So machine A has seriously performance problem, machine B has seriously availability problems, machine C has serious quality problems. Therefore, the improvement approach should be different for each machine. So how to improve availability? So if availability is low, investigate breakdown related problems. Ask why is the machine breakdown? How often does it fail? Which component fail most often? What is the mean time between failures? What is the mean time to repair? That is your MTBF or MTTR. So then another one is changeover problems. Ask why long does setup take? Which activities requires machine stoppage? Can setup activities be performed while the machine is running? Can tool be prepared in advance? So possible in lean method or methods. Use TPM. So preventive maintenance, predictive maintenance, autonomous maintenance, SMAD, root cause analysis, 5Y, fishbone, basic analysis, standard work. So how to improve performance? If performance is low, investigate small stops, records number of stops, duration of each stop, location of the problem, reason for the stop. Reduce speed. Ask what is the standard cycle time? What is the actual time? Why is the operator running below standard speed? Why is the operator running below standard speed? Is the machine capable of the settled idle cycle time? Is the material causing instability? Is the tool worn? So reduce speed. Why the reduce speed? So these type of asks the problems. So possible to improvement method, standard work, autonomous maintenance, POCA-IP, process optimization, tool improvement, machine parameter optimization, small step reduction, operator training. How to improve quality? If quality is low, investigate what defects are occurring, which defects is most common, when does the defects occur, is the defects related to startup, is the process unstable, is the machine condition changing, is the operator following standard work. So these type of problems are there. So useful in lean and quality tool include POCA, root cause analysis, type Y, fishbone diagram, species, statical process control, standard work, fast piece inspection, error proofing, process capability analysis, and POCA and OE. POCA means mistake proof or error proofing, mistake proof or error proofing. And the goal is to prevent error from occurring or detect them immediately. So the goal is to prevent error from occurring or detect them immediately. Example, suppose an operator can install a component into two different orientations. One orientation is correct and the other creates a defective product. A picture can be designated so that the component can only be inserted in the correct orientation. This causes defects and improvement. So quality is related to OE. So 5Y and OE. And the 5Y technique is the useful. The 5Y technique is useful when OE is identified as a major loss. So problems, machine stopped for 30 minutes, stopped for 30 minutes. Problems, machine stops for 30 minutes. Why? Why? First, why? Why the machine stops? Because of the sensor failed. Second, why? Why did the sensor fail? Because it became contaminated. Third, why? Why did it become contaminated? Because dust accumulated around the sensor. Fourth, why did dust accumulate? Because there is no regular cleaning standard. Fifth, why there is no cleaning standard? Because the sensor had not been included in the autonomous maintenance checklist. The root cause is not simple sensor failure. Sensor failure. The root cause is not simple sensor failure. The deeper issue is lack of appreciate maintenance standard. Lack of an appreciate maintenance standard. The corrective action could be updated the autonomous maintenance checklist. OE dashboard. A production team can monitor OE using a dashboard. A typical dashboard may display. So plant production time, downtime, operating time, total production, good production, defective production, availability, performance, quality, OE, measure down region, measure defects region, product targets, actual production. We are the dashboards. Example Example parameter results. Plant production time 450 minutes, downtime 15 minutes, operating time 400 minutes, total production 2000, good production 1920, defective production 80, availability 88.9%, performance 83.3%, quality 96%, OE 71.1%. And this given the production team has clearly picture on the machine. This given the production team clearly picture on the machine. So what is a good OE? So what is a good OE? So commonly referred the benchmark is 100% OE, and this represents no downtime, production at idle speed, no defects. In other words, 100% OE is the perfect production. However, achieving and maintaining 100% OE in a real manufacturing environment is generally extremely difficult. A commonly cited benchmark framework is OE generally interpretation. 100% is perfect. So OE general interpretation. 100% is the world class means perfect. So 85 or higher than often consider world-class benchmark territory. 85% and so higher often consider world-class benchmark territory. 60% typically starting point for many problems. 40% significant improvement opportunity. These numbers should be treated as benchmark, not universal rules. So these numbers should be treated as benchmark, not universal rules. The company should primarily focus on improving its own process and eliminating its largest losses rather than chasing an arbitrary percentage. So why blindly chasing 85% we can be dangerous? Why blindly chasing 85% OE can be dangerous? We should not become we should not become a target that encourage bad behavior. For example, suppose a production operator know the management wants OE above 85%, they may avoiding recording small stuff, ignore defects, change the idle cycle time, run equipment safely, avoid plant maintenance, produce unnecessary inventory. This creates misleading OE numbers. Therefore, OE should be used to expose problems, not hide them. The purpose is to improvement, not simple achieving a higher percentage. Okay, OE should be based on accurate data. OE should be based on accurate data. Accurate data is extremely important. If downtime is not recorded correctly, availability will be incorrectly. Availability also will be incorrect. If the idle cycle time is incorrect, if the idle or standard cycle time is incorrect, performance will be incorrect. If defects are not recorded, quality will be incorrect. Therefore, companies should establish clear definition for plant production time, downtime, setup time, idle cycle time, good parts, defective parts, rework, scrap, and startup losses. Every should use the same definition. So practical OE calculation example. Practical OE calculation example in production line. So let's consider a real world-class production line. A factory produces automotive components. For shift 8 hours. Break 30 minutes. Plant production time 480 minus 30 for 50 minutes. So downtime equal to breakdown time 30 minutes, changeover time 20 minutes, material waiting 10 minutes. So total downtime equal to 60 minutes. So operating time equal to 450 minus 60, so 390 minutes. 390 minutes. So 390 minutes. So production equal to idle time equal to 50 seconds per parts. In idle or standard in production, standard cycle time 50 seconds per part. Total production, so 1400 parts. So defective parts 70 parts. So good parts 1400 minus 70, so 1330 parts. So this is the production 1330 parts production part. So availability equal to 390 divided by 450 into 100, so 86.67 production percentage. Performance operating time 390 into 60, so 23,400 second. Performance equal to 15 into 1400 divided by 23,400 into 100, so 89.74%. So quality equal to 1330 divided by 1400 into 100, so 95%. We equal to 86.67%, 89.74% into say 95%. So approximately 73.9%. We is approximately 73.9%. How to read the result? How to read the result? So OE result is not enough by itself. We need to look at three components. Yeah, is this example availability equal to 86.67%, performance equal to 89.74%, quality equal to 94%, 95%, OE equal to 73.9%. The lowest factor is availability. Therefore, the first improvement priority should probably be downtime. So the team should investigate what caused the 30 minutes breakdown, why did changeover take 20 minutes, why was the material unavailable for 10 minutes, which problems occurs most frequently, which problem causes the greatest loss. Then OE loss tree. OE loss tree. A useful way to understand OE is through a loss tree. Plant production time. So is go for the availability losses, breakdown, setup, changeover, adjustment. So then operating time. Then go for the performance losses, small stop, idle filling, reduce speed. Then go for the net operating time. Then go for the quality losses, scrap reward, scrap rejects. Then go for the good production. This show how plant production time is gradually reduced by different losses. So example of an OE loss tree. Suppose a shift has 480 minutes, plant breakdown 30 minutes, remaining 450 minutes plant production time. Then breakdown plus setup, so 50 minutes, remaining 400 minutes operating time. Then speed losses and small stop reduce effective production. Finally, some produced are defective. And the final result is the number of good parts actually produced. So OE measures how effectively the available production time was converted into a good product. So this is the real example. This is the real example. Then OE and capacity. OE and capacity. OE is also useful for understanding production capacity. Suppose a machine theoretically could produce 1000 good parts per shift, but the actual production is 700 good parts. There is a gap of 300 parts. So before buying another machine, the company should investigate where the existing machine losses can be reduced. Where the existing machine losses can be reduced. For example, 100 parts lost due to breakdown, 100 parts lost due to breakdown, 180 parts lost due to slow speed, 50 parts lost due to small stop, 70 parts lost due to defects. Total 300 parts. OE helps identify these losses. So OE and continuous improvement. OE and continuous improvement. We follow the lean principle. So we measure, identify loss, find the root cause, improve, standardize, monitor. So we under continuous improvement. This type of process will follow. For example, step 1 measure OE 65 percentage. Step 2 identify the largest losses. Availability is loss. So investigate. Most downtime is caused by repeated sensor failure. So root cause use 5 why and find the underlying cause. Fifth step, improve, change sensor protection and introduce regular cleaning. 6. Standardize, update the maintenance standard. 7. Monitor, always increase from 65 to 72 percentage. This is continuous improvement. So OE and standard work. So OE and standard work. Standard work is important because OE depends on having a reliable standard. For example, if the standard cycle time is 10 seconds, if the standard cycle time is 10 seconds, but nobody know how the standard was established. Performance calculation may be misleading. The organization should define standard cycle time, standard operating method, standard machine setting, standard inspection method, standard changeover procedure, standard changeover procedure, standard maintenance activities. The actual performance can be compared against a meaningful standard. So this is the main work. So in first we is first mention the standard cycle time, then standard operating method, then standard machine setting, standard inspection method, standard changeover procedure, standard maintenance activities. Then the actual performance can be compared against the meaningful standard. So common mistakes when calculating OE. So mistake 1, including plan break as downtime. If the machine is not scheduled to run during launch, the launch break generally should not reduce availability. So mistake 2, using only machine running time. So O is not simple runtime divided by O is not simple runtime divided by shift time. If consider availability into performance into quality. So this is the machine runtime. And mistake 3, ignoring defective parts. A machine producing many defective parts cannot have excellent OE simple because it's run continuously. So quality must be included. Mistake 4, ignoring small stops. So a 30-second stop may lock insignificant. So but if the occurs 100 times, 30 to 100, 3000 seconds. So 3000 seconds, so 3000 divided by 50 minutes. Therefore, small stops can create major losses. So mistake 5, using an unrealistic idle cycle time. If the idle cycle time is incorrect, if the ideal or standard cycle time is incorrect, the performance and therefore OE will be also incorrect. Changing definition for shift to shift. So one supervisor may count setup as downtime while another may not. This may OE data unreliable. So standard definition are essential. You know, one more thing is topic is OE versus productivity. OE versus productivity. OE and productivity are related but different. So productivity generally measure output relative to input. Productivity generally measure output divided by input. For example, parts per labor hour, parts per labor hour, or output per machine hour, parts per labor hour, or output per machine hour. So we especially evaluate equipment effective using. So availability, performance, and quality. Therefore, a company can improve productivity without necessarily improving OE and vice versa. Then OE versus efficiency. So efficiency can have many different definitions depending on the organization. For example, efficiency equal to actual output divided by standard output into 100 percentage, which is more comparative because if combines availability past performance plus quality. Therefore, OE specific equipment effectiveness metric, while efficiency is broader for term. Then OE versus utilization. So this term should also not confused. So utilization generally asks how much of the available time was the equipment used. OE asks when the production was planned, how effectively did the equipment operate, considering down speed and quality. Therefore, utilization and OE answer different questions. OE is different industry. OE in different industry. OE can be used in many industries, including automotive, electronics, food processing, pharmaceutical manufacturing, plastics, metal manufacturing, packaging, chemical processing, textile manufacturing, consumer products, semiconductor manufacturing. The exact loss categories are definition may need to adapted to this specific process. So in simple factory example, so I will give you a simple factory example. Imagine a bottle filling machine. The machine is scheduled to operate for 8 hours. The machine stops because of 30 minutes breakdown, 15 minutes changeover, 10 minutes material shortages. So it also experiences. It also experiences. So small stock reduce wastage. So small stock it also experiences. Small stock reduce speed. So finally, some bottles are rejected because of incorrect filling volume. So instead of simple saying the machine worked for 7 hours, we ask we ask availability, how much schedule time was lost and performance, how fast did it actually run, quality, how many good bottles were produced. Then all are the combined into OEM numbers. A simple way to remember OE. A simple way to remember OE. So you can remember OE using a three question. Availability, was the machine available? Performance, was it running fast enough? Quality, did it make good products? Then OE equal to A into availability into P into quality. Availability, performance into quality. I remember available plus fast plus good equal to effective. Available plus fast plus good equal to effective. Then another question is OE improvement example. Suppose a machine initially availability is 75%, performance 80%, quality 95%. Suppose machine initially availability 75%, performance 80%, quality 95%. OE 75% into 80% into 95% equal to 57%. Now the improvement team takes action. Improvement 1, reduce breakdown, availability improves 75% to 85%. So in improvement 1, reduce breakdown, availability improves 75 to 85%. Improvement 2, reduce small stock, performance improve 80 to 90%. Improvement 3, reduce defects, quality improves 95 to 98%. Now OE, 85 into 95 into 98, so approximately 74.997%. Then, therefore, 57 percentage is approximately to 75 percentage. This is the significant improvement without necessarily purchasing a new machine. So, how to conduct an OE improvement project? So, how to conduct an OE improvement project? A practical OE improvement projects can follow these steps. Step 1. How to conduct an OE improvement project. A practical OE improvement projects can follow these steps. Step 1. Select the machine. Choose bottleneck machine. Select the machine. Choose bottleneck machine, high cost machine, frequently falling machine, critical production equipment. Step 2. Establish the standards. Establish standards. Define plant production time, idle cycle time, good product definition, defect definition, down categories. And step 3. Collect data. So production time, downtime, breakdown time, setup time, number of parts, good parts, defective parts, cycle time, small stops. Then calculate OE, calculate availability, performance, quality. Then OE equal to availability into performance into quality. And step 5, identify the largest losses. Do not immediately try to solve everything. So do not immediately try to solve everything. Find the biggest loss. For example, breakdown 120 minutes, changeover 20 minutes, small stop 15 minutes. And the biggest loss is breakdown. Starts there. So step 6, you got to perform root cause analysis. Use tools such as 5Y, piston diagram, Pareto analysis, fault tree analysis, cause and effect analysis. So step 7, implement countermeasures. Implement countermeasures. Example, preventive maintenance, tool improvement, operator training, SMARE, POCAICA, standard work, autonomous maintenance, process parameter optimization. These are the implemented countermeasures. Step 8, measure again. After implementing improvement, calculate OE again. Compare before improvement versus after improvement. And standardize. If the improvement works, update procedure. So if the improvement works, update procedure, update checklist, train operator, update maintenance standard, continue monitoring. And this prevents the problems from returning. So Pareto analysis and OE. Pareto analysis and OE. Pareto analysis is extremely useful for OE improvement. Suppose downtime is reason and downtimes. Motor failure 80 minutes, sensor problem 15 minutes, changeover 35 minutes, material shortage 10 minutes, material shortage 20 minutes, cleaning 10 minutes, other 5 minutes. So instead of treating all problems equally, the team should focus first on the largest losses. So the motor failure is the biggest contributor. Therefore, investigate it fast. And this follow the lean principle. Focus on the vital few rather than trying to solve everything at once. OE and daily management. OE and daily management. So we can be viewed hourly, perceived daily, weekly, monthly. A daily management board may show metric, target, and actual. Availability 90%, availability target 90%, actual 86%. Performance 95% target, 91% actual. Quality 99% target, actual 97%. So E equal to 85 percentage target, so the actual 76%. Then the team can then discuss it. What went wrong, what are the biggest losses, what is the root causes, why action will be taken, who is responsible, when it is be completed, did yesterday action work. This turn OE from a reporting metric into daily improvement system. OE and operator. OE and operator. Operator are extremely important in OE improvement. Operator often know about problems that may not appear in reports. For example, an operator may say the sensor stopped working whenever this particular material is used. And that information may help identify recurring root cause. The operator can also support autonomous maintenance, cleaning, inspection, lubrication, basic machine checklist, abnormality identification, standard work, small improvement. We should therefore use with the operator involvement rather than simply being a management KPI. So we and maintenance. We and maintenance. Maintenance play an important role in availability. So important maintenance metrics include MTBL, mean time between failure. It measures the average operating time between failures. So higher MTBL generally indicate better equipment reliability. MTTR, mean time to repair. It measures the average time. It measures the average time required to restore equipment after a failure. So lower MTTR generally indicate faster recovery. For example, if a machine fails 5 times during a period at the total repair in 10 hours, MTTR could take divided 5 in 2 hours. The team can then work on preventing failure, improve MTBA, reducing repair time, improve MTTR. Both can be support better availability. We and smart. We and single minute exchange of time. So SMART means single minute exchange of die. So SMART is a lead method for reducing changeover time. Suppose before improvement, changeover 60% 60 minutes. After SMART, changeover 25 minutes. Then the machine gains 60 to 60 minus 20, 35 minutes of additional production time. This can improve availability and increase in production capacity. So we and autonomous maintenance. We and autonomous maintenance. So autonomous maintenance is a TPM activity where the operator performs Basic equipment care. Activity can include cleaning, inspection, lubrication, tightening, abnormality identification. For example, an operator discovered a loose bolt during a daily inspection. The problem can be corrected before it causes a major breakdown. This can prevent downtime and improve flow. So OE and quality at the source. OE and quality at the source. So lean emphasizes producing quality correctly at the source instead of allowing defect to continue through the process. The organization should detect problems early, stops when necessary, identify root cause, prevent recurrence. This reduces quality losses and improve OE. So OE should not be used alone. OE should not be used alone. OE is powerful, but it should not be the only manufacturing. OE is powerful, but it should not be only manufacturing KPI. Other useful metrics include safety, productivity, scrap rate, fast pass yield, through output, cycle time, lead time, MTBF, MTTR, on-time delivery, cost, customer complaint, inventory. A company should avoid improving OE at the expense of safety, quality, customer requirement, employee well-being, or overall business performance. Improve OE formula. Improve important OE formulas. Plant production time. So plant production time equal to schedule time plant stop. So operating time equal to plant production time equal downtime. Availability available to operating time divided by plant production time into 100%. performance. So idle cycle time into total time divided by operating time into 100%. That is the main important OE formula. So quality equal to good count divided by total count into 100%. OE availability into performance into quality. So one complete formula example. Suppose plant production time 450 minutes, downtime 15 minutes, operating time 400 minutes. So idle cycle time 10 seconds. Total production 2000 pieces. So defective piece 80. Good pieces 1920. So availability equal to 400 divided by 450 into 100. So 88.89 percentage. Performance for operating time 400 divided into 60 and 24,000 seconds. So performance 10 into 2000 divided by 24,000 into 100. So 88.33%. So quality 1920 divided by 2000 into 100. So 96%. We equal to 88.89 into 83.33 into 96. So approximately 71.1 percentage. Therefore, we equal to 71.1 percentage. What does the 71% work percent? It tells us there is a significantly opportunity for improvement, but we should not simplify say we need to increase OE to 85%. Instead of we should ask availability why are you losing 11.11 percentage performance? Why we are losing 16.67 percentage quality? Why we are losing 4 percentage? Then identify the actual causes. For example, availability losses, breakdown, changeover, material waiting. Performance losses, small stop, slow machine speed. Quality losses, dimension defect, startup rejects. Now the improvement team can something actionable. The most important idea about OE. The most important idea about OE. OE is not just a percentage. The percentage is the final result. The real value comes from understanding where are we losing time, speed and quality and why. For example, an OE 70% by itself does not tells you enough, but this information does. 10% loss for the breakdown, 5% loss for the changeover, 8% loss for the small stop, 4% loss for reduced speed, 3% loss for the defects. Now the organization can decide where to improve. An easy real life analogy. Imagine a taxi driver. The taxi is supported to operate for 10 hours. Supposed to operate for 10 hours. Available, the taxi is unavailable for 2 hours because the maintenance. So it's available for only for 8 hours. Performance. When the driving, the drive, so when the driving, the driver spend time in traffic and the drive below expected average speed. So quality. Some customers are unhappy because of service problems. So we combines these three dimensions. Similarly, for a manufacturing machine, availability was the machine running, performance was the running at the expected speed, quality did it produce good products, the way it is, and that is the way it is. Way it is. And interview answer in way. So what is OE? A good answer. OE stands for the overall equipment effectiveness. It is a lean manufacturing and TPM metric used to measure how badly equipment is utilized during plant production time. OE is calculated using three factors: availability, performance, and quality. The formula is OE is availability into performance into quality. So availability measure down losses, performance measure speed and monitor the stop losses, quality measure defects and yield losses. So we is mainly used to identify six big losses and prioritize continuous improvement activities. So one more interview. interview your example. Give me an example of OE. So you can say, suppose a machine has 450 minutes of planned production time. It loses 50 minutes due to the breakdown and setup, so that the operating time is 400 minutes. If the idle cycle time is 10 seconds and the machine produces 2000 parts per pieces, so performance is 83.33%. If the 1920 parts are good, the quality is 90%. Availability is 88.90%. Therefore, we is approximately 71.1%. And we would then analyze the major availability. We would analyze the major availability, performance, and quality losses and take corrective action. The key point to remember. So, if you remember only few things about why, remember these. Why has three components: availability, performance, and quality. Therefore, we equal to availability, performance, and quality. So, availability asks why was the equipment available when losses? Why was the equipment available when losses, breakdown, setup, changeover, adjustment? Performance as why was the equipment running at expected speed when losses, small stop, idling, reduced speed? So quality as did equipment produced good products when losses, scrap, rework, startup defects, and produce defects. 6 week losses are equipment failures, setup and adjustment, idling and monitoring stuff, reduce speed, process defects, reduce failure, startups losses. So final summary is that overall equipment effectiveness is a powerful lean manufacturing metric used to understand how quickly a machine or production process converts planned production time into good quality products. It combines three important factors: availability, performance, and quality. So availability tells us how much you planned production time was actually available for operation. Performance tells us whether the equipment was operating at its ideal speed. Quality tells us how much the production was the good for the first time. We helps companies identify the 6 week losses, including breakdown, changeover, small stop, reduced speed, defect, setup losses. However, the purpose of OE is not simply to obtain a higher percentage. The real purpose is to identify losses, find their root cause, implement, and sustain the gains. So a good way improvement cycle is measure, then identify losses, then analyze root cause, then improve, then standardize, and then monitor. This is the cycling process. Y equal to 6%, then find a major losses, breakdown are the largest losses, perform hypo analysis, improve preventive maintenance, reduce breakdown, availability improvement, then Y increases. This is how we support lean manufacturing, PPM, Kaizen, continuous improvement, productivity, and equipment reliability, and waste reduction. And this is the another part video. And this video I will explain that in PDF way. So that one also same topic in overall equipment effectiveness. So let's start it. This is very interesting topic. So let's start. So this is the overall equipment effectiveness. So that is the aims and objectives of the overall equipment effectiveness. And then that the content is like that: introduction, overall effectiveness overview, measuring OE at 6 week losses, data collection, how to eliminate losses, what are the benefits. Then he explained that what is OE. OE is a overall equipment effectiveness, is a total measure of performance that relates the availability of the process to the productivity and quality. Then what does that mean? OE is a key performance indicator. So OE is a key performance indicator, so that can measure the impact of change of the process caused by eliminating process and equipment losses. Why OE is so important? Why OE is so important? If you were told that your department was running flat out, you might reasonably assume that the equipment was running efficiently and effectively. Then what if the then my question is that what if the equipment only ran for 75% of the time? What if when it ran at 80% of its speed? What if only 90% of the part it made are good? Individually, these performance measures seem to indicate an okay piece of the equipment, but it is a two picture. What impact on this performance figure? So that is the how do we measure an OE? So OE equal to availability into productivity and to quality. So OE and the 6 week losses. So OE and 6 week losses. So equipment at total total available operating time, actual operating time, effective time. And 6 weeks was a planned downtimes, breakdown, setup or adjustment, idling or minor stoppage, speed, defect in process, and rework, startup losses. Then availability. So I will the percentage of the time. So the percentage of time equivalent is actually running when we need it. So availability equal to available time minus unplanned downtime into 100% is equal to available time. So no planned downtime could be PM, no schedule work, performance, no schedule work, breaks, etc. Available time or available operating time, breakdowns or setup adjustment, planned versus unplanned downtimes, planned excess capacity, planned decks, planned maintenance, communication briefs, team meetings, unplanned losses, breakdown, setups and adjustment, late deliveries or the material operator availability. So note, plant times such as breaks, meetings and maintenance can be considered as losses, useful for encouraging idea on how to minimize their disruption as long as consistent approach is taken. Productivity. What is productivity? The difference between the potential output and actual output when it is equipment was available. Productivity ideal cycle time into actual output divided by actual output into 100%. So availability operating time. Note actual output is the quantity of the good and the bad. So available operating time, actual operating time. So what is the problem? Ideal minus stoppage speed. Then operating speed versus productivity. Operating speed rate, the percentage of the actual cycle time against ideal cycle time. Productivity, the operating speed rate factor to the interruption to the consistency processing, that is idling or minor stoppages. Then quality. The total good part produced expressed as a percentage of total parts produced. Quality equal to part made minus defect quantity into 100%. Parts made. So actual operating time, effective operating time. So defects in the process and rework, startup losses. So process versus defect quantity. Parts made. The total quantity of parts produced in the available time. So defects quantity, the quantity of parts that did not meet the required standard, including rework in the available time. The OE and the 6 week losses. So that is the OE and 6 week losses are there. So that you can remember because before I will explain that type of topic. And 6 week losses, what are they? 6 weeks losses, what are they? First one is breakdowns. The time lost due to key equipment breakdown or retroson which cause the production to be stopped for more than 10 minutes. That is the breakdowns. The time lost due to key equipment breakdown or retroson which causes the production to be stopped for more than 10 minutes. Then second one is the setup or adjustment. The time lost through product changeover and adjustment to the point where the production of the new product is completely satisfactory. That is the setup or adjustment time. Idling or that and third one, idling or minor stoppages. The time lost through key equipment being stopped for less than 10 minutes. The time lost during the standard cycle time when the equipment is not adding value. That is the idle or minor stoppages. Fourth one, speed. Fourth one, speed. The time lost through key equipment not producing part at its optimum rate. That is the speed in the machine. Fifth one is defect in the process and rework. The time lost through key equipment not produced part that meet the specified quality standard. The time lost through key equipment being utilized to rework substandard parts. What are the then another one is another loss is startup losses. The time lost through key equipment not producing part to the specified quality standard, following startup and before equipment achieve controllable production condition. So how to collect data per week? So key points are OE is a measure of the equipment or process, not the operating productivity. Keep it simple. Ensure the process of measuring and applying OE involves the people who use this equipment. Make data collection second nature, not a hindrance. Understand the process. Obtain the data on fixed frequency. Snapshot versus continuous. Units of times 1 minute, 10 minutes, 30 minutes, etc. Automatic or manual data collection. Ownership. Partnership. Those completing seed or those collecting or collecting. Regular communication of the results. Response to trends or pick and through. Then how to collect data for OE. So this is the how to collect data OE in 300 data sheets, 3 hourly data sheet. This is one example. So you can make same type of data in 3 to 4. So how to collect data? That one file is there, one Excel is there. You can maintain that how to collect that type of data. Then how to how to eliminate losses. This is the 6 week losses. How to eliminate? You can see that is the image, and so many things are there. How to eliminate and which time to eliminate. You can maintain that sheet, 6 week losses sheet. How do we use OE? How do we use OE? OE is only a measure. Its benefit will be lost if the shortfalls in identified are not acted upon. OE is a total measure of performance, but the data used to produce it must be used to prioritize improvement tasks. The purpose of measurement is to identify losses, remove waste, and drive improvement. OE should be used to support the total productive maintenance approach and the tools it supplies. Then what are the benefits of OE? What are the benefits of OE? Focus highlights prioritize purchase. Simplicity. Even complex process can be measured. Feedback. Before and after change. Benchmarking. Objective comparison. Targeting setting. Setting achievable goals. Solving problems. So many problems are there in production, estimating equipment uptime or downtime. So question, thank you. So thank you for this video. This is my part 2 video. Let's talk about the part 3 video. This is one more example in OE, overall equipment effectiveness, and that one also most important PDF in this section. So this is PDF, you can read that PDF now, then automatically you can understand in everything. So let's start about this video. So this is the background of the OE. So background is a management, operational wise or business wise. So operational wise, overall equipment effectiveness, business wise, asset utilization. Asset utilization and OE indicates so how the factory is being managed in the operational or business perspective. So OE definition. OE is a index. OE is an index which calculates the equipment operating state and judge if the equipment is utilized at its fullest or not. So OE is the main factor. Then OE calculation. OE equal to availability into performance rate into quality production products rate. So it is calculated by multiplying together the equipment of availability, performance rate, and quality rate. An overall assessment in terms of the three attributes of time, speed, and quality. It indicates the proportion of the time for which the equipment is actually adding value or not. Calculation OE availability indicates the extent downtime. Performance rate indicates the scale performance losses. Quality products rate indicates size of products defect losses. Then OE calculation. So this is the OE calculation scenario. So you can see that image. We have to calculate in OE. So see that image, you can understand how to calculate the total time, loading time, operating time, total time, loading time, operating time, net operating time, value of present time, and how to calculate availability, performance, and quality. So see that image, then you can clearly understand. Note standard cycle time based on the designated maximum speed as defined as the losses definition. Defects units include only when the waste got in the quality of the river. So we calculation area harm and all are mentioned. So see that image. And this is the 16 losses calculation. See, this is the 16 losses in we. So in company, this is the OE. Suppose you not implement, then 16 losses are there. Total time and loading times, shutdown, the operating time, equipment breakdown, changeover, cutting change, setup, remove, management operation, motion, etc. Net operating time, minor stoppages, speed, line operation, logistics, value operating time, defects and reward, measurement or adjustment. So, and 14 was energy and 15 was maintenance and spare parts. So, there are and 16 was yield. So, loss definition, equipment breakdown, unplanned equipment stoppage more than 10 minutes. So, minor stoppage, unplanned equipment stoppage less than 10 minutes, minor stoppage. Loss definition, changeover, time taken for a changeover from last product at nominal speed and quality until the first product of the next run at nominal speed and quantity. That is the changeover time. Time taken for a changeover from last product at nominal speed and quality until the first product of the next run at nominal speed and quantity. That is the changeover. Cutting blade change, time taken to change item used in the process which have worn out. Example blades or reels etc. Then startup or shutdown. Startup is the total time taken to achieve nominal speed and quality. Startup time is measured after any plant stoppage, not including changeover. Shutdown is the total time taken to shut down the line and establish appropriate condition for an effective startup. Six losses definition. Speed losses from running the line at a speed less than standard cycle time for a particular product. Speed losses from speed losses from running the line at a speed less than the standard cycle time for a particular product. So defects and revert. Time lost in producing non-conforming product or time to revert a non-conforming product. Then short down. This is caused by stopping the equipment for periodic plant activity like maintenance or inspection. It will have maintenance or inspection or for a legal inspection for during the production stage. This also includes holiday, weekend, no plant modification, trial, etc. And one is the management. These are the waiting time management. These are the waiting time losses generated by management problems. Example, failure to provide materials, spare parts, waiting instruction, utility, etc. And operational motion. Losses due to difference in skill level or to inefficient layout. That is operational losses. Then one more losses is that line organization. Losses due to shortage of operator. Example, during the break. Logistics. Time wasted due to the inefficient delivery of raw and packing materials. Product to line and removal of finished product from the line. That is the logistics. So one more is measurement and adjustment. Frequent measurement and adjustment to prevent a recurrence of problems. Example, quality of routine and unexpected cleaning and sanitization are also considered here. Then this is the diagram. So I'll explain that. So asset utilization. This one first is overall equipment effectiveness. Then let's study the business. So business management. First one is asset utilization. Definition. An index which measures utilization of the lines, taking into an account the impact of factory shutdown on availability. Calculation asset utilization loading time into 100% divided by total time. Asset utilization loading time into 100 divided by total time. How efficiently is the line being utilized from business point of view? So capacity planning. So TCM or COP loss history. So total time. So shutdown losses, loading time, operating time. So net operating time. So you can understand that image. So this will show in everything. So you can make this A type of format. Then you can understand. Then six big losses. Six big losses. Let's start. The six big losses visualized. The six big losses was visualized. See that image that you can understand the six big losses in this manufacturing field. So OE definition. So see that is overly explained in the OE definition how the losses, how the failures, how the availability, performance, quality, everything will mention. Then availability. Availability when equipment 6 luggage calculation. How the availability is there. So see that the example where he will explain that availability. Then a measurement measuring availability. Data collection sheet. That is the measuring availability of the data collection sheet. So you can make that PDF or this type of format, then you can understand these things. Another measuring availability, data collection sheet codes. So data collection sheet codes. So mentioning the different types of data plant maintenance PM and meals and rest MR meetings empty traffic tier non-materials and MCM types. So we short form you will clearly explain that. Then performance rate. There are different types of in that performance rate you can right side see that is how to performance rate that you will calculate. Then you can understand. Then measuring performance rate. How do we measuring speed loss rate and everything. Then this is the speed loss rate, speed set speed by standard speed. This is speed loss rate, and the set speed is the spend as set on machine. The standard speed is maximum speed of the bottleneck machine making the particular product based on designated or specification designated speed when capacity higher speed. Minus stoppage loss rate. Actual production divided by utilization time into set speed. Set speed. Note the minor stoppage loss rate accounts for all non-recorded downtime, which consists mainly of the minor stops, failure less than 5 minutes, non-recorded. Performance rate, minor stoppage loss rate into speed loss rate. So this is you can compare about that these two. So you can find the main solution. Meeting performance rate data collection sheet. So meeting performance data collection set, you can make that meeting performance data collection set, and this is very important. So quality rate, then for the third one is quality rate. How to quality rate make that one you can maintain that things quality rate. So how to maintain then you can do it. So measuring quality product rate. So how to measure it when see that image one by one you will explain in the production line. So quality data registration. Quality data actual production defects defect the actual production. So good production equal to good right. So overall equipment effectiveness is like that. So availability, performance and quality. These are the overall equipment effectiveness. So we have availability and quality quality. I think what good quality product loading time is standard speed. So 52.6 per RAM. Then Pharmaco versus TPM losses analysis. So this image you can understand about the Pharmaco versus TPM losses analysis. Then Pharmaco versus TPM losses analysis. Pharmaco OE includes a large break as a routine stoppage. TPM OE does not include meal breaks or downtime losses. Therefore, OE is greater than or less than OE. So, to confirm the Unilever Pharmaco includes the meal breaks into TPM downtime losses that OE equal to OE. Monitor each of the six losses individually along the calculation of pharmacoe or P and TPM availability, performance rate, quality product rate, as well as generating of loss tree, showing all six losses. Knowing each of your 6 week losses, it's more important for improvement than knowing your OE or OE. Then this sporadic versus chronic losses. Sporadic is chronic losses. Then this is the restoration type. Countermeasures are needed to reduce the rate to its level. Improvement type countermeasures are needed to reduce the losses to the limit. And loss cause structure. Sporadic loss. Single cause. One cause is responsible for loss. Sporadic loss. Multiple causes and compounding causes. Then all losses are caused by ourselves. The production floor is the source of losses. So 6 week losses, failure, minor, stoppage, defect, startup, setup, speed. We can cause the losses of ourselves. Circumstances are logical situation exist cause losses, but these losses cannot be discovered directly. Symptoms of failures are not clear. Wear and tear is not evident. Defects are not evident. So one way of thinking must change. Philosophy and prevention. Preventing is essential. Target is zero. It is important to eliminate the sources of failures and improvement. This is the psychology of prevention. How to prevent is essential. Control, understand logical reasons, and this is you can control and understand the logical relation. It is not sufficient to notice the losses or problems and how to attack losses. Decide definition of losses which occur on site. Establish a mechanism to measure the above losses. Identify losses structure. Emphasize on losses and take tasks to reduce them. Study approach for reducing each losses. Make trends of each loss clear. So definition of the losses, define the losses by name, characteristics, examples. More than one name is being used for the same losses. Failure, breakdown losses, minor stoppage, idling losses, quality defect, rework losses, setup and adjustment, changeable losses, reduce speed losses, startup or short-term field losses. And second one is measure losses. Establish a mechanism to measure the losses. Who, what, when, where, how. That you can measure the losses. Identify loss structure. So you can identify benchmark equipment or lines. And how to identify the loss structure. You can make that file. Then emphasize on the losses and the tasks to reduce them. So focus on the large losses, consolidate the losses into Kaizen thems. Then this you can improve. Then study approaches for reducing each losses. Focused improvement. YY analysis to reduce loss by 95%. PM analysis. Plant maintenance analysis to reduce loss to zero. Plant performance improvement. Setup change. Overtime analysis system. Autonomous maintenance. Plant maintenance. Training and education. And equipment maintenance. So this is the make trends of each losses clear OE graph. So 100% of the six losses. So you can understand it clearly. So then make trends of each losses clear. So in the loss tree, and this is the loss tree. You can make that tree. Then how to clear, how to problem is coming. So you can maintain. Then labor productivity and OE. So labor productivity overall equipment effectiveness cycle time into meaning. So kg per man hour, so 1 by kg per into man. So total labor productivity you can reduce cycle time by upgrading or replacing the equipment, reduce the number of operator by automating the equipment, improve OE by reducing the 6 week losses. Improving OE is the easiest way to improve labor productivity rather than into capital investment. Thanks for your attention, and this video suppose you will helpful. So please like and share and subscribe this channel. So then this is the another 6 big losses. Same topic. 6 big losses are there. So I will explain. So you can see that is the 6 big losses. So that is I think the third time you see that image, then no need to then go for the another losses. 16 big losses are there. So this is the 16 big losses. So you can read that losses. See that is the 16 big losses. So how to maintain this type of losses structure during production activities and at which position is the losses. See that is the one by one. I will explain that. See that image and clearly and carefully. Then one by one he will explain that what is first one is failure losses, how to fill these losses, and he will explain in everything so you can understand about this failure losses. So see that is the image of the failure losses and general problems with failures. Then how to general problems are being failures, he will explain that. So you can see that is the general failure losses. Then another topic is explain that relation of cause and effects of failures. These type of failures relations are there. Failures, moods, strengths, process depression, living stress alone, insufficient waste condition. How to sort out this method? So see that is one by one. He will explain that. So results and cause of the human error something. And setup and adjustment losses. Setup and adjustment losses. See that is the image. He will explain that one by one in full details. You can read it one by one. Then you can understand how to set up his losses. That so adjustment, another losses is adjustment means the following. Adjustment means the following. So he will mention that adjust how to take and how to approach that the things. Then another is the one set of defects changeover. So changeover, test grinding measurement, repeat adjustment. This is the one step of the over. And this is the changeover grinding measurement, continuum grinding. Then why cannot we achieve one step defect free changeover? We assume that adjustment are simply investigated in a high precision process. Our implement and replaceable parts of poor precision, so we can make adjustment to compensate. The standard mounting points are not clearly defined with a numerical value to the case identity. So you can read it on one by one. Then steps for promoting single step defects free changeover. So this one you can read in one by one, then you can clearly understand about that. See, that is the one by one you mention, and one by one you read, then you can clearly understand. So this is the machine operator and how to operate and how it is lost. You can see that image. And this one another is the cutting blade losses. So cutting blade losses, how is it how it did happen. So he will explain in the clearly, then you can read that one by one. Then another one is startup losses. So startup losses, you can read that page. This is the startup losses. Then method of reducing of startup losses. We will maintain that method of reducing of the startup losses. Then another one is minor stoppage or idling losses. The definition of these losses is as follow: minor stoppage or idling losses. Which generate problems of minor stoppages. And defects or rework losses. You can read that in defect and rework losses. And basic principle of quality maintenance. And overall equipment effectiveness. OEE. A formula and how to use a formula can measuring the equipment utilization and performance uses an industry standard its values downtime region the data record and we will explain that in details. Overall equipment formula. See that is how to maintain that overall equipment effectiveness and we will explain availability equipment availability performance efficiency quality rate. For OEE and how to calculate that formula, she will explain that in one by one. Then a relationship between six major losses on equipment and overall equipment effectiveness. So this is parasite, you can clearly understand about the 6 week losses and overall equipment calculations. Then you can understand in everything. And this is the 6 week losses. Same thing, you can understand about that one by one. And overall equipment effectiveness. For calculating the OE for the line, in the line considered as the entity mentioned in or out. Set up out and overall plant effectiveness. For OP, major losses. See that is the major losses, which area is losses are there, we can mention that. Individual improvement. Sporadic and chronic losses. Sporadic and chronic losses. Chronic problems. An approach to chronic losses, loss reduction. And this is the end of for the video. Then I will explain that system measures losses. Then this one also one more 16 major losses video. So you can clearly see that image also. I will just image I will show you. So your requirement wise you can read and understand about that. Then the 16 major losses. Major stop and equipment failures. Then 6 major machine losses and equipment efficiency. Then overall equipment effectiveness. OE analysis flowchart and data source. Data source. Number major stops equipment failures. 8 big losses in process plant. So 1 second. Wait. 8 big losses. Definition and example of the 8 big losses in the process plant. Then overall production efficiency. Regular production losses or irregular production losses. Data collection and cascades are general milestones. Daily data log example, for. 4. data cascading. This is the last video for measuring the manufacturing performances V and TEP. So I'll simple just explain that you can read in paper topic. So this is simple. You can just read it. Measuring performance in TEP, total overall equipment effectiveness and overall equipment effectiveness. So these two are. So let's starting again. I will explain that manufacturing performance way. This is the way you can read and understand about that. And this is the TEP. So you can read and understand about the topic. And this is the OE and TEP. See that image, you can clearly understand about that in everything. This is the OE and 6 big losses. This is the countermeasure of the 6 big losses. This is the end of our video. So I think you can understand in everything. So thank you so much for this video, for watching. So thank you. Suppose if you are interested in this video, and next video I will explain that DPM related topic in the lean manufacturing. So thank you so much.